So we see a lot of airports over here. It's no problem to us. We'll make the video second part. No, it's okay, no problem. So I missed one part of the video. I will have to restart again because I pressed the button by mistake. So I will start showing you again the same things. I will talk to you about the displays and the functions of the Boeing 787-900Z aircraft. You can see the primary flight display that displays the airspeed indicated, the airspeed selected from the autopilot flight director system panel, ground speed, the radio altitude above the ground level, barometric altitude above the sea level, the target altitude selected from the autopilot and flight director system panel. Target altitude, also vertical rate of climb descent of the aircraft in 10 kilometers and 1000 feet per minute, or the signals with chronometric angles increase, you can climb the descent. We have also the Lszh localizer with instrument landing system, the radio frequency transmitter receiver that transmits radio frequency from the terrestrial antennas of the runways we use for takeoff and for landing. So we can see also we can use also the onboard antennas of the aircraft to receive the radio signal, so we can align with the runway when we approach for landing with the Lszh localizer, the horizontal localizer, and the vertical glide slope for approach and landing. So we have to tune a unique radio frequency each time we take off and land from different airport and runway, and also magnetic north pole shading for approach and landing. We have also the flight mode annunciator with the autopilot and the autothrottle, later on vertical navigation modes, the radio altitude above the ground level, parametric pressure, HSI, the horizontal situation indicator that displays the magnetic heading and track, also the integrated display of the flight plan. We have also here, you can see, so this is the aircraft I will talk to you about. So you can see we have another aircraft is coming for landing right now. Over here, it approaches the Boeing 737-800. So you can see the primary flight display here, the navigation display, the instruments that we have. Also the aircraft, the Boeing 787, the outside view. Hope you like it. We'll show you all the instruments as much as we have time for that. So you will see also the navigation display, the terrain and weather reflections from the weather radar. You can see the red, green, yellow indications of the terrain around the aircraft. The distance is displayed depending on the distance of the aircraft, and also the altitude difference above the ground and in front of us. We have mountains also in the terrain map. You can see the airports, the 4-letter account name, the airport runways, the taxiways we use for takeoff, for landing. Also the heading of the runways, magnetic heading. We have also other airports. We have the waypoints, the worst stations, ADFs, the waypoints, which are for the level navigation rigs. When altitude and airspeed consider, you're gonna set up the flight management computer. In a few minutes, you will see I will use the flight management computer to input all the data we need for this flight. So we'll set the flight management computer and complete a flight plan very quickly. You can see also the primary flight display here, the airspeed indicator. 30 nautical miles per hour, now 200 knots. The airspeed selected from the autopilot, and the altitude selected from the autopilot terrain. Also around us, you can see the airports where they are located, the elevation of the aircraft when it's flying. Over here, we're gonna see. Also the flight controls. You can see here we have the display, the computer I'm using, the mouse pad, and the keyboard. I need to input the data over here for the autopilot, the flight management computer. Also you can see the flight, the side stick I have here for climb descent, make turns to the left, make turns to the right, so we can climb and descend. I have the side stick dedicated to the Airbus aircraft to use for the Boeing 787, so we can climb with the same. You can see the vertical column over here of the Boeing 787. Also we can make turns to the right, turns to the left. We can use also the rudder pedals over here to make left and right turns, directional steering. Also, we use it for the forward nozzle. We have also the horizontal trim stabilizer over here. We can trim the horizontal elevator of the aircraft for climb and descent over here, as you can see. So we climb, we trim the elevator up, we descend, we trim the elevator down like this. So this is the elevator pitch trim. As you can see, it reads in the tag elevator trim, left click down, right click up over here, right click up, left click down, right click up like this. So it's very easy to remember and to learn. You can see here we trim this way the elevator, we pitch the elevator up, we pitch the elevator down, trim the elevator up, we trim the elevator down. Also we have other flight controls. I will show you the other also the systems of the aircraft. So we have you can see here is the horizontal tail in the outside view. So when we move the side stick for climb and descent like this, we can climb, we pull the elevator up, we pull the elevator down, use the side stick or the control the side stick in the Airbus, or the yoke in the Boeing 787 for climb and descent like this. Also make turns to the right and to the left. Very easy to remember. I will show you also the outside view. So you can see also we have the horizontal trim stabilizer over here that I was talking to you about. So you can trim the elevator up, trim the elevator down, pitch the nose of the aircraft up, pitch the nose of the aircraft down. You can see elevator trim control over here as it reads. In the tag, elevator trim, left click down, right click over here up. So very important flight control part. You can see how many degrees you pitch the nose up, the elevator up or down, and also pitch the nose of the aircraft up or down accordingly. So we can see stabilizer for 0.35 degrees. Right now it's at the green band for takeoff. So this is the horizontal tail stabilizer. We have the rudder trim also in 0 position, 0 degrees. The flaps are fully extended. The landing gear here extend and retract. Also other systems we can see in the ACAS sends indication and crawler system display. So we have the landing gear over here, extend and retract, alternate gear over here, lock override. Also the auto brakes, rejected takeoff, maximum for approach and landing. So we have also the displays. You can see the N1, which is the low speed starters have low pressure compression tube and the turbo handle, which is engine the left and the right, the exhaust gas temperature per engine, the N2, which is the high speed starters have high pressure compression tube and of the turbo handle, which is engine the left and the right. I will show you in the outside view. Also the fuel flow of the engine with each engine left and right per hour, 1000 kilograms or thousands of pounds, solid pressure, solid quantity. And also the vibration in inches of the N2 stage of the engine. So you can see the cabin pressurization also here, the outflow valves position for pressurizing or depressurizing the aircraft when we climb or when we descend. When we climb, we open and close the outflow valves to pressurize or depressurize the aircraft. They receive pressurized air from the engines, that's why maybe are displayed here. So this also when we climb to like 43 or 45,000 feet, the cabin altitude inside the aircraft will be like 6, 7 or 8,000 feet maximum pressure, differential pressure of 7.8 or 8 psi. You can see the rate of climb descent, the outflow valves position when we open and close for. We have it in the auto right now. We use the manual channel for pressurize or depressurize the aircraft. We have to use also the outflow valves. You can see also the cabin, the gross weight for takeoff, total fuel board, the fuel temperature. I will show you also the autopilot flight director system panel right now. So you can see here we have the cabin pressurization, the outflow valves for climb descent. We can use the auto. In the manual you see the yellow indication light, which is a warning, so we have to use the outflow valves open and close when climb or descent to pressurize or depressurize the aircraft cabin. This also affects the oxygen inside the aircraft. You will see also other systems. In the overhead panel you see the electric system, the hydraulics, over here the flight control computers, air data computer, over here flight control surfaces, the battery, Over here FD door, towing power, also your passenger oxygen with the heat, fuel system, electronic engine control for the engines with the auto start also. So you'll see one system by one, fire, cargo fire, APU fire, other recorders, battery, down power, flight controls, hydraulics. Also we have the fuel on board, fuel system, left and right wing, fuel tank, center tank, crossfeed valve, balance, we're gonna use the IF. So we're gonna need some systems here in the overhead. You're gonna see in a couple of minutes how we're gonna use them for starting the engines of the aircraft. So you can see the aircraft, the Boeing 787 over here. So we'll talk to you maybe a little bit about the flight controls of the aircraft. So you can see the display, the airspeed indicator right now, as I told you, airspeed 8, vertical rate of climb descent of the aircraft 10,000 feet per minute, the altitude indicator, artificial horizon. So you can see 2.5, 5, 7.5, 10 degrees, 12.5, 15, 17.5, 20 degrees for pitch up and pitch down. When we climb or descend, radio altitude above the ground will display up to 2,500 feet. Barometric altitude 1,430 feet above the sea level. Right now the elevation above the sea level over here in Zurich, Switzerland airport. We have also vertical rate of climb descent. So this needle moves up when we climb, moves down when we descend. It shows the altitude difference. So we climb 1,500, 1,000, 1,500, 2,000, 3,000, 6,000. Also we descend at the same rate. So you can see the barometric pressure setting over here. Right now it's 29.9 degrees of mercury over here. So this affects the barometric altitude, which is given to us from the air traffic control tower. So we set over here from the FE's panel, electronic flight instrument panel, inches of mercury 29.92 or 1013 hectopascals. We can increase or decrease the value. Will give us a different increase or decrease of the barometric altitude above the sea level. We have also the radio altitude from the radio from the signal of the antenna of the aircraft. For compare also when we fly, we have also terrain display, red, green, yellow indication in the navigation display. So this is the terrain elevation depending of the distance away from the aircraft, also the airports. So I will show you also this view. We have all the radar traffic train on the display, the range increase and decrease, system CDU info, checklist, communication. This is for the display over here of the systems, the engines, the systems, electric, hydraulic, fuel. Those later, autopilot, flight director, system panel, you can see autopilot. Engage and disengage, auto throttle left and right, engage and disengage, flight director, LNAV and VNAV. The airspeed select knob, use later. I will set the airspeed, also heading 360 vertical speed, and the altitude select over here. So we'll select the different values for all these things. So I will show you the stabilizer trim right now. Over here we have the stabilizer trim. We can pitch the elevator up, we can pitch the elevator down, trim the elevator up, trim the elevator down. Also this gives an aerodynamic effect and the nose up or nose down as we fly. You can see the parking brakes also set. The higher stabilizer left and right, the auto trim disconnect over here, left and right cutoff switch also. The fuel cutoff switches, the engine left and right thrust levers over here. Also you can see, very important, the cutoff for the stabilizer trim and how to use the pitch trim. The fire extinguishers for the left and right engine, the transporter, high frequency radio communication, the rudder trim also. So in the thrust levers you can see we actuate the thrust commanded by the engines. Also the flight controls and the stabilizer trim right now of the Boeing 787, how I use them. So you will see now we are almost here, 34. So you will see how I use the stabilizer trim right here. Also the flight controls, climb and descend, also the thrust levers. So we make left and right turns. We have the thrust control over here and here. in the side stick, the Lszh Extreme 3D. We can advance the thrust levers. You will see the engines indication displayed, increase or decrease. So you will see the warning, configure, will not configure for takeoff, like this. You see all the values changed as commanded by the FAREX. The FAREX are the full authority digital. The full authority is electronic control computers. One installed per engine gearbox, dual channel redundancy. One channel phase, the other takes over. Controls monitor display all the engine data you see in the upper and lower ACAS. Also the autopilot, I will show you the flaps and the speed brakes, the stabilizer trim. So we'll continue with the stabilizer trim over here. We can trim the elevator up, trim the elevator down like this. You can see the elevator, the outside view over here. So we can also climb and descend and also trim the surface, which is a flight control of the aircraft. Also use the rudder, other flight controls, make left and right turns. So I'll talk to you about the aircraft flight controls, how we can use the trim of the elevator also. So this is a fly-by-wire aircraft. It has its flight control computers. You can also trim itself automatically. When we fly, we don't need to do nothing for that, it's automatic. So you can see also we have another aircraft coming for landing over here. A Boeing 737-800, as you can see, just landed. So we can trim either manually using the switch here and the alternate channel of the alternate switch, or we can leave the aircraft trim itself automatically from the flight control computers like the Airbus aircraft. When we fly, it has its auto trim, the Boeing 787 and Boeing 777, to balance the aircraft in flight, in level flight in 1G, to maintain 1G, where 1G is the acceleration of the aircraft gravity when it flies straight in level, or when we make left and right turns. With the Airbus we have 2.8G in left and right turns, or 67 degrees of the side of deflection. When we climb 30 degrees or 1.5 G. When we descend minus half G or minus 15 degrees. So you can see here we climb with the Airbus side stick 30 degrees or 1.5 G. We descend minus half G or minus 15 degrees, and also we make turns 67 degrees left and right, or 2.8 G. We can let the side stick at full deflection, and with the Airbus it will maintain a 33 degrees bank angle in the left or the right, and we'll have to use the side stick again to maintain the level flight. Also we have the alpha protection, the alpha floor in the Airbus aircraft. When we reach the 1G stall and angle of stall of the aircraft and the speed of stall, it will give us a takeoff lock, takeoff ground, thrust lock, and also it will decrease the angle of attack of the aircraft automatically. So we have similar protections. We have other speed protections. The Boeing also has similar protection from the flight control computers. Also the auto trim system over here. The flight control computers you can see here. So we have a failure of the flight controls over here because of the hydraulic system failing over here, either left and right engine driving. It will degrade the modes of the flight control computers from normal to alternate or direct mode. We'll lose the autopilot because we won't have the automatic trimming. We need to come down here. This is for Boeing 737, Boeing 747, Boeing 757, Boeing 767, Boeing 777, and Boeing 787. You open from normal to cut off here and disconnect the auto trim function. As you can see, normal to cut off either the left tail or the right tail with auto stabilizer. You can see left and right tail, so we can use either one for trimming and for climb and descent. And you use only the alternate pitch trim switch over here after that for climb and descent. Also you can use the manual all the time to direct the normal, as we say, climb and descent like this, elevator up or elevator down. In this control also the yoke all the time. So I will show you now the outside view of the aircraft. I will talk to you about the Newton's physics and the Bernoulli theory of fluids, aerodynamics. and aerospace engineering, we need to know for the air transfer pilot license, the commercial pilot license, the ATPL theory and the CPL theory. So you see the outside view, we have a few minutes to set up the flight management computer and the rest of the systems. So we go in the outside nav view over here. So you can see the outside view, you can see we have the mean aerodynamic chord with the maximum aerodynamic lift occurs. We have the lift from the left and the right wings. The weight of the aircraft is divided over the surface area of the wings. So we have the thrust vectors from the jet engines. These jet engines, you can see we have the high pressure compressor and turbine and high speed starter and shaft and spool, and also the low pressure compressor and turbine and low speed starter and shaft. Also the combustion jabber, the bypasser, also used for the thrust reverse of the engines of the Boeing aircraft. We have also the fuel flow to the engines from the suspension coming down here, where is the left and the right. Wing fuel tank over here is also the low and high pressure fuel valve and the fuel booster pumps. We have also the where is the main aerodynamic chord is the maximum aerodynamic lift. Also the center of pressure moving back and forth. The stall also will occur here. We need to avoid the stalling flight. We have the center of gravity coming down through here, where the main aerodynamic chord is. Also the center of gravity is the yaw axis. We use the rudder to make left and right turns like this, as you can see. The rudder pedals control, and we have also the nose wheel simultaneously. When we fly, we have only the rudder. When we are in the ground, we have both the rudder and the nose wheel to make left and right turns until some airspeed from 0 knots up to 45 knots or 72 kilometers an hour. We can use the left and the right turn on nose wheel automatically from the computer when we press the rudder pedals up to 76 degrees left and right turn. When we reach 45 knots or 72 kilometers an hour, the forward nose wheel deflection is limited by the computer automatically to 7.6 degrees. So we use here the rudder pedals, as you can see, to input left and right turns from the nose wheel or the rudder when we are in the air. So we have also the tiller for the left and the right captain and first officer side. So we have also when we accelerate further above 80 knots or 144 kilometers an hour, the rudder only controls the aircraft in takeoff, as you can see, left and right turns, and the forward nose wheel from the computer is locked to 0 position or half of 1 degree deflection, very small deflection. So also when we land the aircraft, first we have the rudder, and then as we slow down below 80 knots, the nose wheel becomes activated from the computer. So this is how we control the yawing of the aircraft. We have one more axis over here from wingtip to wingtip. It's the pitch axis. We can climb and we can descend the aircraft like this. As you can see, climb and descend. I use the elevator, the side stick in the Airbus aircraft. Also, we use the yoke in the Boeing 787, as you can see, for climb and for descent the aircraft. Very easy to remember. Also, we have the horizontal stabilizer trim, and we have one more axis here from nose to tail is the side stick left and right. In the Airbus is the Boeing left and right control wheel, with ailerons and spoilers in the Airbus, and also in the Boeing we have the flaperons. You can see left and right input give us a differential air pressure between the left and the right wing. Will give us a turn either to the left or to the right, like this. Left and right side stick, very easy to remember. Also the speed brakes now fully extended, the flaps and the slots. So we have a few more minutes. I will show you also. So this is the control wheel, left, right and left turns, control column, climb and descend, all flight controls together. Also I will show you one more view very quickly of the flight controls of the Boeing 787. Then we're gonna set up the flight management computer very easily to set up the flight plan for the aircraft to fly using the autopilot. So you will see now how I can control over here. The flight controls shows the view. So we have the control here. We can climb and we can descend the aircraft, either the Airbus or the Boeing aircraft, as you can see. We have the side stick priority button for the Airbus, for either side the push to talk and the autopilot disengage. So we climb with descent like this. You can see the side stick deflection is proportional to the yoke of the Boeing aircraft, no difference in the flight controls feeling when you fly with the other one. So we climb, descend, make turns to the right, make turns to the left. Also horizontal trim stabilizer. Also we have the thrust levers, thrust control. You can see how many degrees. Over here actuate the thrust levers. So this is how to control, very nice. I hope you like the side stick from the Airbus that I have to control my Boeing aircraft over here. So climb, descend, make turns to the right, make turns to the left, and also one more view over here. You can see climb, descend, make turns, rudder pedals. Over here ailerons and spoilers, as you can see, very easy, very accurate like in the real aircraft. Also ailerons and spoilers like this. So this is all for the flight controls lesson for tonight. I will show you now the rest of the aircraft systems. We need to set up the flight management computer very quickly. The flight management computer now will use the mouse pad here and the keyboard to input all the data we need over here. So we input the data of the aircraft for this flight using the mouse pad. It takes the control here, so we have the index. I will show you identity, position, performance, takeoff, announce approach, announce status, flight plans. So we go in the index again. I will show you this view maybe. So we have the control quadrant over here. So one more nice view of the aircraft. The Boeing 787, we have identity, position, performance. So identity, Boeing 787-900 GNX engine. Position, we set the airport, and this will align us with the GPS and also the IRS, inertial reference system, magnetic north pole, geographic north pole, coordinates, longitude, latitude. Performance, you have 0 fuel weight plus fuel on board, gross weight for takeoff, reserve fuel, cruising altitude, cost index, fuel freezing temperature, and cruising center of gravity. The route from this airport, Lszh in Switzerland, back to Lszh over here in Switzerland. So copy paste, clear the discontinuity, runway 14, departures over here. So the departure runway and departures runway 14. We can select either runway Zui to Alpha. Then arrivals, we have arrivals runway 16, runway 28, runway 34, ILS 14, ILS 16, ILS 28, ILS 34, GLS 14, localizer 28, localizer 34. So we select ILS 14. Trans-Amity over here, waypoint transition, and Trans-Negria over here. So we have the legs, the route is created, displayed with blue, is going to be followed by the autopilot with cancel or discontinuity here in the Amity. So this is what the autopilot will follow in flight, one waypoint by another from takeoff, climb, cruises and approaches and line. So we have the performance now to activate it. Gross weight for takeoff, 0 fuel weight, gross fuel on board, cruising altitude 35,300 feet, and the cost index 100%. Fuel freezing temperature, cruising center of gravity. So we press the green lighted switch, the execute button. It will activate the flight plan. Now it can be used by the autopilot. First waypoint after takeoff, 2 nautical miles, 250 knots, 1900. We make left turn 1356 nautical miles at Zui. We climbed 301 knots, 6000 above the sea level, heading 05 52, then Nigria 071 heading 26 nautical miles from Zurich, 301 knots, flight level 22,200 feet. We make a right turn, Motive 230 degrees, heading 12 nautical miles from Nigria, 320 knots, 11,000 with the sun, Miki 6 nautical miles, Zurich 9 nautical miles, Zurich 7010, 6 nautical miles from Zurich, 108 knots, 6,000 alpha, then TRA 10 nautical miles, C114, Osnem 5 nautical miles, runway 14. So we align with the runway here. We make a left turn for approach and landing. Initialize here flat approach for landing. Center of gravity 28%, 4.85 degrees. V1 we rotate, V2 gross weight, runway position. So we have the route departure or alternate VNAV progress FMC communication. We can hold over a waypoint, use the fix or the navigation radio, tune Lszh localizer for instance. So we go back over here, back to the cockpit as you can see. So we can set over here. We can see the displays are different. We'll see the flight plan also that we have to fly through. Also you can see the runways and the taxiways we can use for approach and landing. Over here our own runway, the terrain in front of us. When we fly you will see the aircraft above the ground. Also the other plan over here, so we can use either one for navigation purposes. We have also, I will show you over here, I show you the systems, the electric lights on, left and right IGG, 180 200 volts, 400 Hz frequency, 100,000 kilovolts, the battery, primary flight control computers, the auto position, heading, air data computer, flight control surfaces, battery, empty door, passenger oxygen over here, window heat, rammer, turbine, backup, hydraulic and left right engine driving. As you can see in the off position will display some fault display, so we turn back on, then to the auto position. We can get engine guide over here as you can see on our auto position. Pressurization as I show you, outflow valves in the manual, climb and descent, open and close the outflow valves, pressurize the aircraft, pressurize air from the engines and DPU for oxygen, cabin pressurization with an engine RDIs, hydraulic fluid tanks pressurization. Also we have the fire extinguishers, the recorders, the electronic engine control for the engine with the auto start modes over here. You can start the engines like this. Fuel jettison, we can dump some fuel, select the nozzles and how much fuel to be made, make an emergency landing like this. Also we have fuel booster pumps, crossfeed valve, we turn it on, you can feed either engine with other pump or either tank and balance the fuel between the left and right wing. So this is what we need to do. We have a few more minutes for the displays here. Over here display the systems very quickly, the format. So we have systems, we need to know hydraulics over here, pressure of the hydraulics, IPU is running, oxygen, quality liquid cooling, electrics, left and right IGZ, 100 200 volts, 400 frequency, the APU is running. Also the battery charge and discharge over here, main battery and APU battery, the voltage and the average. So we can see also the hydraulics, where the hydraulic fluid goes, which system use hydraulic fluid, left and right engine, driving, primary demand, electric C1, C2, isolation valves, shut-off valves, pressure 5,000, 100 psi, as you can see, in the quantity of hydraulic fluid. Fuel, left and right wing, fuel tank, center tank, 11,000, 11,000, 11,000 total, 33,500. The minimum fuel temperature below which the fuel we freeze in flight over here. As you can see, we need to monitor the FAREX will control automatically the transfer of fuel. You can see minus 37 degrees minimum fuel temperature right now. So this is automatic from the computers that control the engines. The transfer of the fuel from the left and right wing, fuel tank and the center tank into the engine components to heat up the fuel, then return the fuel back to the wing and center tanks. So we have the long high pressure fuel valves open and feed both engines. The cross-feed valve with an automatic feed either engine with either pump. Also the EPU is fed from left wing using this motor. Also the recirculation of fuel also recirculates the lubricant and the oils for defreezing. We have the pressure for cabin pressurization from the engines and the EPU, oxygen, other systems. The doors are closed, the cabin can be pressurized, the gear, temperature of the brakes, pressure of the tires, flight controls, left and right flight controls over here. So we climb with the sun. This is the last thing we need to see, the tail or the stabilizer position, rather titles also. FS display, maintenance, circuit breakers, maintenance over here. The checklist, normal menu, what to do before start, after takeoff, descent, approach and landing. Checklist, communication, navigation display. So we need to see the engines. We're gonna turn them both off. We have a couple more minutes. Both engines in the off position. We're gonna restart the engines, as you can see. Both engines on. And you see the warnings, the yellow warnings, because the engines are off. So we look outside, you can see the airplane, and we have some more minutes to go over here. So you can see the aircraft. We need to restart the engines very quickly. So go in the overhead panel, both engines in the auto start position like this. Very quickly. You're gonna see now we're gonna have pressurizer from the APU. The auxiliary power unit is gonna pressurize the engine starter and to above 25%. We can start the fuel flow. So you can hear we have only pressurizer right now. So we let the fuel control both on position. So you see now we have the auto start coming in. Auto start open. All systems now of the engine. We have fuel inside the engine. Running with pressurizer from the APU. To start the engine starter. Since the hydraulics are back. 50% you're gonna see the messages going off because the engines are running now. So at 62% we're gonna be having green, both green, so we can go for takeoff. Flaps set up, speed brakes up. So we have 30 more minutes for this. We need the airspeed, the LNAV and the VNAV, like this. The airspeed set, you can set the airspeed. This is the autopilot control. So we have the left and the right auto throttle, like this. The flight director off, we will disarm the modes. Autopilot disengage like this. Also heading, bank angle limit. Heading we're gonna set the heading of the runway, we're gonna use for takeoff and for landing. Vertical speed over here, zeros. We can descend like this. You can see the minus sign. We can climb, you will see the plus sign. Also the altitude thousands like this, and hundreds. So this is the autopilot now set. We can disarm the parking brakes. We go into the runway for takeoff. We take the clearance from the air traffic control. So the runway is open for us. We use idle thrust for taxiing, as you can see. We use also the tiller for the taxi. So the runway is open for us. Taxi into position here. So here we are ready for takeoff. So thank you for watching. I'm Thomas Hatsios, the German American pilot flying the Boeing 787. We just started the takeoff process. Stay with me until for the full flight. So you see takeoff, go around thrust, set, push the side stick down a little bit. Also flaps up for takeoff. So we push up. We have 130 V1. We rotate V2. We pitch 9 degrees for takeoff or less to maintain to not hit the tail in takeoff. So we pitch up slightly like this, as you can see. We can also see the system. So we have 17 more minutes for this flight. You can see we are 1,100 feet above the ground, as you can see as we climb. You can see the terrain, red, green, yellow. You can see we are 1,800, 900, 2,000 feet above the ground, about 3,500 above the sea. The airspeed 2,400 above the ground, 4,000 above the sea. The stall speed, red and yellow, the wind direction speed. We climb with this rate over here, climb rate 3,900 feet per minute. You can see the terrain, green, yellow, and red as displayed. Also the flight plan, purple flight plan. Also we can see over here, if we fly closer view, you can see the view over here. We are 3,600 feet above the ground, 3,700. You can see this green line is the ground below us as we're climbing over here in the red color display. Also the ground around us, so we have some awareness about the ground. Also the head-up display. So we need to start the turn now. 4,500. So you can see the airspeed and the stall speed. We use a bit more flaps as we climb. Landing gear also, forget up. Landing gear up. So we need to climb and also depart the runway down and now the airport. So you can see the view of the Switzerland. We need to start the turn now, align with the flight plan. So we have 15 more minutes to go for this flight. You can see we can leave the hands off on the side stick, no problem with that. Also have the flight plan on the other side, as you can see as we're climbing. So we have 15 more minutes for the flight to complete. We have a beautiful view over here, as you can see. The star sign, very beautiful. And also the aircraft, the Boeing 787, as we're climbing. So hope you like the Boeing 787, and we have 13-14 more minutes for the flight to complete. We need to align over here a little bit. Over here, follow the flight plan. As you can see, the beautiful view over here, the Switzerland, the Swiss Alps, also the Germany. We're gonna fly over in the France, very close. And we have 13 more minutes left. Maybe we're gonna be flying with the other pilot, maybe manually. You can see the aircraft cockpit just after takeoff. View of the cockpit, I hope you like. Also the overhead of the Boeing 787. You can see this is the first waypoint we need to intercept now, the Zui over here. A couple of nautical miles. The wind direction and speed, the airspeed 167 knots, the stall 120 knots with the red and yellow. We climb 1100 feet per minute. So we need to make some turn over here, climb maybe a little bit higher. As you can see, use some right rudder pedals, follow the LNAV also, navigation. Use a little bit the right rudder for this turn. So we have 12 more minutes left for this flight. So we have the LNAV over here. Keep climbing, 18,000. Also the autopilot settings, gonna see it later, the head-up display. So we need to fly through these waypoints. The Nigri is 24.1 nautical miles away from us. We need to override this waypoint, as you can see in the legs page. Right through Maldives now, as you can see, then through Amiki. So we have the view over here. We're flying over the France, my homeland Germany in front of you, Bayern Munich, and the Switzerland, and we are almost the lakes. So we start the turn, and we have perhaps 11 more minutes. So we divert a waypoint over here, as you can see. This is how to divert the waypoints in flight. Hope you see it. I just click over the display and I change the waypoint. So we are 20,000 feet overflying here. We keep flying manually, as you can see, and we overflying this view, very nice view, the Boeing 787. And the view of the Germany here, Bayern Munich, the lakes of the Switzerland and the Swiss Alps, the France, the Düsseldorf very close to us, and the Bayern, the Munich. So we climb here. We keep turning, we align with the flight plan, this purple line, and we have 10 more minutes left to go back home. Maybe we connect the autopilot just for display, you see how it works. When we align with the flight plan like this, flaps up also. So we can align with the autopilot like this, auto throttle on 253, decrease the airspeed, the angle of climb. So we gain some airspeed like this. So this is how we climb now with the autopilot, and we have 6 more minutes to fly on the route. So you can see the autopilot now is engaged, autopilot on. Over here also in the panel we have the autopilot mode, and here autopilot engaged. So we need to follow the route now. Over here we have 7 more minutes to go back home. So we have this beautiful view over here, overflying this area. Also we can increase the airspeed right now. So this beautiful view, and we have 7 more minutes to go back home. Beautiful view of the Switzerland, frozen vapors, the chemtrails, and the beautiful star sign of the galaxy. And we have 7 more minutes for approach and landing. The Germany behind us, my homeland Bayern Munich, and the France in this side. So we keep going, and we need a few more minutes. Descent approach now, maybe. We need to start descent, decrease a little bit the airspeed. Also the descent rate, start descent. And now the altitude also. So descent rate a little bit less. So we keep descending like this. Also we can take out the manual thrust over here. Speed brakes also. And we have 6-7 more minutes to descend over here. We have some overspeed, we need to decrease the airspeed like this. Descending. So we are very close to the approach over here. We have also the view of the cockpit as we are descending again. One more time. To descend a little bit more. So we need to follow the route here, as you can see. This waypoint, the Ilsloc waypoint. Now we're flying manually, as you can see. So we start the turn like this, manually. And we have 5 more minutes for approach and landing. So we put a little bit left rudder for the turn, as you keep descending. As you can see, full manual turn over here. We need to align with the runway position here, the head of the runway. And we have 4 more minutes for the flight record to end. So we need to approach a little bit faster, as you can see. So now we are aligned with the runway over here. Keep descending also. A little bit to the left over here as we descend. Use some thrust if we need to align. Also the airspeed set over here, heading set. So we advance the thrust levers as we descend, and have a few more 3 minutes for approach and landing. As you can see, all flight controls. Also the approach angle over here, autopilot side. use some landing gear in a couple of minutes. We pass through the river. So we use the landing gear now, and it slow down. Also the flaps set. So we have the outside view as we're descending. As you can see, we need for approach and landing. Over here, having this view. So we need to use a little bit right rudder over here, and some right flight controls. Yoke, also some thrust levers, some engines thrust. So full rudder, right rudder now to align with the runway. We are a little bit off runway alignment. So we have some side wind, some wind gusts. We need to align with the side wind and the wind gusts. Also add some thrust, some flaps, more flaps over here. So we are now aligned left rudder now for the runway alignment. As you can see, we have also the ILS localizer, all the information we need to follow in the displays. A little bit less thrust over here for the engines. So right rudder now again. So we have wind gusts and side wind to align the aircraft with as we approach for landing. A bit more or less idle as we are approaching. Align with the center line and leveling off for approach and landing. We have to see to red and to white. We are a little bit higher for approach. So we're leveling off here. So we have the flare, as you can see, very beautiful. Flare and touchdown. Align with the center line over here. Idle thrust and parking brakes and thrust reverse, full thrust reverse over here. And we are slowing down, as you can see, fully slowed down. We made very beautiful landing, very professional. Keep slowing down. We have some time. You can see the line here is perfectly safe. So we align here again. You can see the thrust reverse over here. So here we are, fully slowed down. You can see all landing gear is perfectly safe. There is no breakage of any wheel or tire, as you can see. The forward nose wheel is fully safe. There is no breakage. The aircraft is starting up. We have the thrust reverses fully deployed. So the aircraft is starting up the way it should be in the runway, as you can see, for another flight from the walk around check. The wings also. You can see also the runways. I'm gonna show you. You can see the thrust reverse. So we use idle thrust reverse over here. Now we'll close the thrust reverse. So you can see the cockpit again one more time. So that was Thomas Hatsios, German America pilot flying the Boeing 7879 hybrid night flight from Zurich International Airport back to Zurich, overflying Germany and France and Switzerland. Thank you very much for watching. We just made a very beautiful morning, full manual flight, and also some autopilot in cruise for display, so you see how it works. You can see also my instruments here, my computer, my joystick. So I'll see you next time. Thank you very much. Bye bye. So the outside view. One more time, the runway over here, and the airport, the Switzerland over here. You can see how much runway we have available. Over here. So that was the cockpit. We can also taxi into the runway if we need. We're gonna do it another time. Thank you very much for watching. See you next time. Bye bye.